Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain the method of chain rule in order to find the derivative of a composite function. So, what is a composite function? Well, if you have a function that, for example, looks like this, then you can see that this big function f here can be made of by having a composite function, which is f compose g of x, where your fx is set x and gx is x squared plus 1. So basically, if you have f compose g of x, therefore we are going to consider substituting gx into x, and so that becomes the square root of x here will be substituted with this one, which is x squared plus 1. And this one here is the big function f, and it is a composite function. So if you have a composite function and you want to find the derivative of it, you can apply the method, which is called the chain rule method, in order to find its derivative. And it is a very simple rule. If let's say you have fx and gx, they are both differentiable, and the composite function is given by this term here. So this is the composite function, and the big function here is also differentiable, and the derivative of this function here can be obtained by using this formula here. So this is the formula given in order to find the derivative of the composite function. So here what we have to do is we are going to differentiate this function. Okay, you're going to differentiate this function and you're going to substitute gx into x. Okay, and here you're going to differentiate this function, so the result here will be multiplied to the derivative of gx. Okay, so perhaps the whole thing is going to become clear if we consider some examples. All right, let's look at question A. So here we have y is equal to the square root of x squared plus 1. And based on this, perhaps you can see that your fx can be square root of x and your gx can be x squared plus 1, such that when you substitute gx into x, so if you have, for example, f compose g of x, so f compose g of x is going to you're going to get this result here. So f compose g of x is going to be x squared plus 1. So if you check, you will get the result as given by the original question here. So based on this function here, you should be able to determine your fx and your gx. Yeah. So if you want to find the value of dy dx, so you want to find dy dx, so you want to differentiate this function here, you can apply the formula, which is this one, times with the derivative of gx. Okay, so if you differentiate this function, so here if you differentiate, I'm just going to write down somewhere here. So if you differentiate f prime x, the answer is going to be 1 over 2 x negative 1 over 2, and that can be simplified as 1 over 2 the square root of x. So the result of this, so this basically means you're going to substitute gx into the result here. Okay, so if we write down the result, it's going to be, you substitute x squared plus 1 into this position, and so the result is going to be 1 over 2 x squared plus 1. So that is the first part. Next, g prime x is straightforward. You're just going to differentiate this function, and the result is going to be equal to 2x plus 1. This is a constant, so it is equal to 0. And based on this you can simplify, so 2 can be crossed out, and you will get the final answer is going to be x and set of x squared plus 1. Okay, so that is by applying the rule which is given here. Yeah, okay, let's look at another example on how we can apply the rule, the chain rule, which has been highlighted in the previous slide. Okay, okay, for example, question B. So here we have y is equal to sine x squared, and based on this I'm sure you'll be able to determine what is fx. So fx is sine of x and gx is x squared, such that if you have f compose g of x, that means you're going to substitute x squared into x in function f. The result is going to be sine x squared, which is what is given by the question here. Now we know that in order to find the derivative of this function, so this is the question here, and we want to find the derivative of it, dy dx is equal to, we're going to apply the formula which is given by f prime gx multiplied with the derivative of gx. So now if you differentiate this function, so f prime x, the result here is going to be cosine of x, and when you have gx, that means we are going to substitute gx into the result here. Okay, so therefore f prime gx is going to be equal to cosine of x squared. Yeah, so that's the result of that. I'm just going to write down that on this part here. So we will have cosine x squared, and if you differentiate function g, you will get equal to 2x. Okay, so that's the answer. Now of course there is another way of looking at this chain rule method. You can think of, this is an alternative way of answering the question here. Well, if you have a function y is equal to sine x squared, you can think of finding the derivative of this function by considering deriving the result of the outer function. You want to find the derivative of the outer function. You can consider the whole thing as the outer function and think of what is the result when you try to get derivative of sine x squared. So we are just going to maintain this part inside the function here. So if you have a function which is sine of something, the derivative of that is going to be cos of something. So we're just going to write down cos x squared. So we just maintain the value here. And next, you are going to differentiate the inner part. So inner part is this one. So if you differentiate the inner part, it's going to be equal to 2x. So we just multiply the result of differentiating the outer function, which is this one, with the result of differentiating the inner function, which is this one. Okay, well, both ways are acceptable. Normally I'll just use this one because it is simple. I have managed to skip a few steps here and get the answer straight away. Yeah, and up to you, which one do you prefer to implement? Well, according to your own comfort, which one it is fine. Okay, right, now let us try and look at question C. Okay, so here we have y is equal to x cubed minus 1 to the power of 100. And based on this, if you want, you can consider your fx to be x to the power of 100 and your gx as x cubed minus 1. Okay, so you can try to test whether your assumptions are correct by considering f compose g of x. So when you have f compose g of x, the value of gx here will be substituted inside x into function f. So the result here is going to be x cubed minus 1, and here we have 100. Okay, so there you go. You managed to do that. I mean, the representation here is correct. Fx is this one and gx is this one. Now, in order to find the derivative of this function, so this is the function and we need to find the derivative of it, we can follow the rule given by the previous slide, which is f prime gx times with g prime x. So this is the formula which you have seen in the previous slide. Yeah, so the step that we are going to do is we are going to differentiate f prime x. So the result here is, if you differentiate this, you will get 100 x to the power of 99. And so if you want to find what is f prime gx, that means you are going to substitute gx will be substituted into x here. Okay, so that's the meaning of this expression here, and the result is going to be 100 x cubed minus 1, and here we have 99. So that's the result, and I'm just going to write down the result properly right next to this one here. So we have 100 x cubed minus 1, 99, and if you differentiate gx, so the result here is going to be 3x squared, and you can simplify the process here. So you will get 300 x squared x cubed minus 1 to the power of 99. Okay, so that's the answer. And if you want, like I said earlier, you can consider a different approach to this. You can consider finding the derivative of the composite function by viewing it in terms of outer function and inner function. Yeah, so here we have y is equal to x cubed minus 1 to the power of 100, and so I can see that this is going to be my outer function, which I need to differentiate first. Okay, and then I am going to differentiate the inner part, which is this one. So this is the inner function, and I'm going to multiply the results together. Okay, so therefore dy dx is going to be equal to the result of differentiating the outer function. So what happens if I differentiate this? Okay, assuming that this can be maintained as it is, we're not going to change it. Yeah, so here I'm going to have 100, so maintain whatever in the bracket as it is. This is 99 times, okay, that's the result of differentiating the outer function. Next, I'm going to differentiate the inner function, which is this one. This is going to be 3x squared minus 1 is minus 0. And again, we can simplify that to be equal to 300 x squared x cubed minus 1 to the power of 99, and you get the same result as given here. Just that by doing this, I just simply skip some of the steps here. Yeah, all right, I think that's all for now. Thank you very much for watching.